Hi, good morning. This is a lesson for Algebra 2, and today's lesson is on solving rational equations. Our aim today is how do I solve for the variable in a rational equation? So we are going to discuss what a rational equation is, what things we have to look for, the concept of extraneous roots, and being able to put it in a way that can quickly eliminate your denominators so that making solving the rational equation a little bit easier. So today we're going to start with this equation that I have here, x plus 4 divided by 2 equals x plus 9. Now think about inverse operations. If you were solving this, you would want to eliminate the division by 2 immediately by taking that 2 and multiplying it on both sides of the equation. But prior to doing this, it is highly important that we put parentheses around each part that we're going to be multiplying by 2. So we're going to show the multiplication by 2 on both sides of this equation. The 2's will cancel, leaving the x plus 4, and then the 2 would distribute into what remains to be 2x plus 18. And the rest we're not going to solve right now. You would group like terms on either side of the equation by subtracting x, subtracting 18, and then solving. Okay, so this is a rational piece because it's a fractional piece. Now what if you had not just the 2 on one side of the equation, but you had 2 on both sides of the equation? What would happen then? You would take your denominator of 2, multiply it on both sides of the equation, canceling the 2's on both sides, and leaving just the x plus 4 equals the x plus 9 to solve. This would have no solution because the x's would cancel on both sides. But what if that denominator were different on both sides? So what if instead of having a 2 on both sides, you started out with x plus 4 divided by 2 on one side and x plus 9 divided by 3 on the other side? Well, now I don't want to do 2 different steps where I multiply this side by 2, that side by 2, then this side by 3, and that side by 3. Instead, I'm going to think of what denominator can I multiply both sides by to eliminate both the 2 and the 3. And that would be the least common multiple of both 2 and 3. So the least common multiple of 2 and 3 is 6. So I'm going to multiply both sides of the equation by 6. That's going to allow me to divide the 2 into the 6, leaving a 3, and divide the 3 into a 6, leaving a 2, which is exactly what would have happened when I multiply by 2 on both sides and then 3 on both sides. Then the 3 would distribute in, and the 2 would distribute in. Then you would distribute, and again, group the like terms together and solve. Okay, well, what if the denominator, instead of being a numerical denominator, was a numerical on one side and a variable on the other? So what if I had a 2 here and an x here? Okay, again, we're going to use the concept of a least common denominator, least common multiple of the denominators that are there. So we have on one side of the equation a 2, on the other side of the equation of x. So I'm looking for then the least common multiple of 2 and x, which is 2x. So 2x gets multiplied on both sides, thereby canceling the 2 here, leaving an x, and canceling the x here, leaving a 2. And then I'd be done. Okay, so what if it wasn't just a monomial x? Let's say it was a binomial x. And the binomial x was an x plus 1 on this side. And maybe on this side it was just an x. Now I have to again think, what is the least common multiple of x and x plus 1? Well, it's x times x plus 1. Because I need all of this represented and all of this represented. And even though there's an x there, I can't break this apart. I have to think of this as a unit. This is the whole thing. So now I'm going to multiply both sides now by x times x plus 1. And over here, x times x plus 1. Now over here, the x plus 1 will cancel with the x plus 1, leaving x times x plus 4. And over here, the x here will cancel with the x here, leaving x plus 9 times x plus 1. Now to solve this, I would need to double distribute my binomials, giving me a trinomial over there, and distribute the x in here, giving me x squared plus 4x. Then again, I would be moving the terms to other sides of the equation in order to solve for the variable. Okay, so in this case, we have to eliminate domain restrictions. Okay, so before we move forward with other examples, let's talk about a little bit about domain restrictions. A domain restriction is something that if I got as an answer, I would have to reject, because if I plug the answer back in, would give me 0 in the denominator. So my domain restrictions, or as I like to call them, my DRs, x cannot equal 0, because if x were 0, 0 in the denominator here would reject that, and x does not equal -1. So x can't be -1 and it can't be 0. So if you were to get those as an answer, you would have to put one line through it, write reject, extraneous. We call those extraneous roots. Okay, so let's start some additional problems. Now that I've warmed you up to this concept, we're going to work on problems. Okay, first one, 2x minus 3 divided by x minus 4 equals 2/3. Okay, so we're going to use the procedure of least common denominator. So if you have to, we're going to go over to the side. We're going to write LCM. We're going to write what our denominators are. And then we're going to write the LCM of the denominator, which is 3 times x minus 4. So first step, before you do anything, this is super duper important to do. Parentheses, parentheses, even a parentheses here. I know it seems silly, but do it, just do it. Get in the habit of putting parentheses around everything, because then you're not going to forget to distribute, and it won't mess you up when you have like minus something. All right, so I'm going to multiply top and bottom by a 3 times x minus 4. 3 times x minus 4. Okay, so when I look at this fraction, the x minus 4 matches the x minus 4 here, thereby canceling the x minus 4 with the x minus 4. It leaves 3 times 2x minus 3. On the right, the 3 will cancel with the 3, leaving 2 times x minus 4. Now, presto, no denominators. This is now an easy equation to solve, and something that you're used to seeing without there being fractions in the way. So the 3 gets distributed in, so 3 times 2x gives me 6x, minus 3 times 3, which is 9, equals 2x minus 8. And now I move like terms to other sides using inverse operations. So I'm going to move the smaller x value, 2x, is going to be subtracted from both sides of the equation. That leaves me with 4x minus 9 equals -8. Move the 9 by adding it to the other side of the equation. 4x equals +1. Divide by 4 on both sides. X equals 1/4. So my solution x equals 1/4. Look back to your original equation. Am I able to use the value 1/4 here? Yes. The domain restriction, x was not able to be equal to 4. I did not get 4. I got 1/4. 1/4 is good. And so that's the solution to the equation. Okay, let's move on to another example. All right, in this next example, going to have two fractions. Let me just open up the page. So we're going to have 1/5 plus 2 over x equals 1/3. Okay. Again, look at all of your denominators. List your denominators. It helps. I know it takes like 2 seconds extra. Go to the side, LCM. You're looking for the LCM of 5, x, and 3. So what can I multiply? What is the least common multiple of a 5, a 3, and an x? Well, if you're thinking 15, you are correct with the numerical part, and you also have to include the x. So 15x is the lowest common multiple of all three of those. So I'm going to take parentheses around everything. And I know at this point, it seems kind of strange to put a parentheses, but the reason why we're going to get into this habit is because these will be binomial or even trinomial numerators, and everything will have to distribute into that. And so it kind of puts us in a good practice for it. So every part gets a 15x. All of this and all of this are multiplied by 15x. So I'm going to put a 15x here, and a 15x here, and a 15x here. Everything gets multiplied by 15x. And now you think, what am I doing to each fraction? What will be eliminated? The 5 will cancel with the 15, leaving 3. 3x times 1 is just 3x. Next fraction. The x will get eliminated. X divided by x is 1. 15 times 2 is what remains. And so 30 is what remains. And then the fraction on the right, 3 divides into the 15 5 times. 5x times 1, leaving just 5x. Now this is so much nicer to look at and easily solved by inverse operations. So we're going to perform an inverse operation, subtracting 3x from both sides, canceling the 3x, leaving the 30. 5x minus 3x is 2x. Divide by 2 on both sides, and x equals 15. X equals 15 is not a domain restriction. My domain restriction was x cannot equal 0, and therefore this is the solution to my rational equation. Okay, so if I substitute 2 over 15, add it to 1/5, I will get 1/3. Okay, so another example. Okay, in this one I'm going to have a binomial in the numerator as well as the denominator. Let's see, so x plus 2 divided by x minus 2 equals -3 divided by x. Okay, binomials, don't forget, we're going to surround everything with parentheses. And I'm going to put a parentheses around this as well because that's a unit. I have to think of that as that whole piece, x minus 2. So my least common multiple, x minus 2 and x. So it's just x times x minus 2. And both sides of the equation are going to multiply by my least common multiple. So to do that, I'm going to show x times x minus 2 here, and x times x minus 2 here. On this side, I think it should be easy to see that the x minus 2 piece cancel with the other x minus 2 piece. What remains is x times x plus 2. On the right, the x will cancel with this x, leaving 1. And what remains is a negative 3 times x minus 2. And now I have to distribute the x with the x plus 2, getting x squared plus 2. I have to distribute the negative 3 with the x minus 2, giving you negative 3x plus 6. And now it's a quadratic with 1x squared terms, so how do we solve quadratics? Make it equal 0. Factor it, solve. So every quadratic has to equal 0. So I'm going to move everything to this side of the equation, add the 3x here, add the 3x here. You get plus 5x. We're going to subtract the 6 in a second and make it a trinomial equal to 0. This is really super important. Quads equal 0. Factor, then a t-chart. This is kind of have to be like an automatic response. It's a quadratic. Make it equal 0. Factor it. T-chart. Solve the factors equal 0. Okay, so I'm at this point. Now I'm going to open up parentheses, and think what two numbers multiply to give me a negative 6 and add to give me a 5. So if you're doing the x method, you're putting the negative 6 on top and the positive 5 on the bottom, and you're thinking, well, I know 3 times 2 gives me 6, but I need to have them have different signs. That means I'm going to subtract, and I can't get 5. So you don't use 3 and 2. What are other factors of 6? 1 times 6. We always forget those. So factors of 6 are 1 times 6, 2 times 3. I need 1 and 6. The 1 and the 6 are going to be able to add up with different signs to give me a positive 5x. So I need a 1x, and I need a 6x, and I need an x here, and an x here, and I need the 6 here, and the 1 here, and I have to add them and get positive 5. So I need the 1x to be negative, which means the minus goes there, and the plus goes there, okay? So if I was doing it in the x method, little chart here, I would put the positive there and the minus there. So x minus 1, x plus 6, okay? Now once you have your factors, these are binomial factors, then you create a t-chart. You split the factors, set them equal to 0. Why? Because of the zero product property says whenever two things multiply to give you 0, one of them or both must equal 0. So in order to solve that, you set the factors equal to 0. Okay, add 1 to both sides, x equals 1. Subtract 6 from both sides, x equals negative 6. Now, I'm not okay just leaving those answers and saying they're it. I have to go back and check my domain restrictions. So, well, here we go. Sorry, I'm going to shrink that a bit so I can see the original equation. And if I plug 1 in here, 1 plus 2, make this a little thicker, 1 plus 2 divided by 1 minus 2 is a 3 over negative 1. And if I put a 1 in here, I get 3 over negative 1 is negative 3. Negative 3 over 1 is also negative 3. So my x equals 1 checks out, and I'm good. Let's check the x equals negative 6. Negative 6 plus 2 over negative 6 minus 2 gives you negative 4 over negative 8. Negative over negative gives you positive. 4 over 8 gives you a half. Equals negative 3 over negative 6. 2 negatives become positive, and 3 over 6 also reduces to 1/2. We are checked out on both fronts, so our solution set is x equals 1 and x equals negative 6. Okay. And let's see if we have one more where we have to add these. Okay, here's one that I want to do that has a little bit of factoring. So this one's a little bit different. They're all a little bit different. This one in particular, it's a very important type of problem. Okay, now we're going to have a binomial in each of the denominators with subtraction in the middle. So we're going to have to come up with our least common denominator. So our problem is 1 over x plus 3. Trap it immediately as you're writing it with your parentheses. Minus, I think that says a 2 over 3 minus x. Ooh. Keep in mind what happens when you reverse a binomial. You factor out a negative. Remember that. And equals 4 over x squared minus 9. Of course it is, minus 9. Okay, so the first thing I'm going to do here is I'm going to rewrite it and write the factors of x squared minus 9. Because I need to come up with the least common multiple. Now, you could rewrite it, or I could just go over to my workspace and come up with my least common denominator. So my least common multiple, I need x plus 3. I have 3 minus x. Keep in mind, if I take out a negative, that's going to flip. And the x squared minus 9 is a combination of x plus 3 times x minus 3. So these are my 3 denominators. This is that one on the bottom, there, and over there. Okay. All right, so it stands to reason then, if I use this as what I multiply each fraction by, I will be able to essentially cancel all my denominators. This one will be an easy to see cancel. This one, when I cancel it, instead of leaving a factor of 1, it's going to leave a factor of negative 1. And then this one will just cancel the entire thing because that's what x plus 3 times x minus 3 is. When you have a conjugate pair, it equals the difference between 2 perfect squares. Okay, so I'm going to need some room to do this. Each of these fractions, all the parts of the fraction, put parentheses around everything. Because in the future, they won't be numbers. They'll be variables. Or they'll be binomials. And you'll need to distribute. So you have to remember you're going to trap everything using your parentheses. Clever use of parentheses will get you far. So everything gets multiplied by that. X plus 3 times x minus 3. First fraction. Second fraction. X plus 3 times x minus 3. Third fraction. X plus 3 times x minus 3. Everything gets multiplied by it. Now you look at each individual fraction. Don't look at anything else. Just look here. What am I canceling? Well, what's the same? Exactly the same. X plus 3, x plus 3. What does it leave? It leaves an x minus 3 times 1. Or just an x minus 3. Next fraction. X minus 3, 3 minus x. If you cross it out, you write a negative 1 on the outside, recalling 3 minus x with a negative 1 distributed out becomes negative 3 plus x, which then becomes x minus 3. So this and this can cancel. I could do the x minus 3 with the 3 minus x as long as I put in a negative 1 in its place. So I have a minus. I see an x plus 3 still there. There's a 2 still there. And there's a negative 1 now. And the whole thing has to be written that way. And the whole thing has to be subtracted. So minus the entire 2 times negative 1, which is negative 2, times x plus 3, big parentheses. Okay, just look at that, take that in for a second, make sure you understand how I moved those terms, combined those, brought that here, and how that was the only thing left, those 3 pieces. So we had this piece, and that piece, all left in the numerator. Okay, and the last part of this should be pretty easy because this entire thing is what this equals, And so that just leaves me with the number 4, and so that equals 4. Okay, now this is so much easier to look at, but we're not finished yet. This -2 has to distribute, and then we distribute the negative in again. So x minus 3, keep it in parentheses, keep this in parentheses for now. -2x minus 6 equals 4. Now we can work in the negative, the minus to the binomial that remains. So we've got the x minus 3 minus -2x becomes plus 2x. Minus -6 becomes plus 6 equals 4. I don't need right now the parentheses around this. So x minus 3 plus 2x plus 6. Using the commutative property, I'm going to reorder my terms, keeping the sign in front of them belonging with that term. And now I can group it. 1x and 2x is 3x. -3 and 6 is 3 equals 4. And look at what we finally got it down to. This little itty bitty two-step equation where we subtract 3 and divide by 3 to get your answer. So let's do it. We're going to subtract 3 from both sides. 3x equals 1. And divide by 3. X equals 1/3. And yes, you are right. We are not done because you have to check that 1/3 is a legitimate answer and that it is not a domain restriction. So let me find the original problem. 1/3. 1/3 can substitute into that x. That's good. 1/3 can substitute into that x. Absolutely won't cancel anything. And a 1/3 squared will give you 1/9, which when you subtract 9 does not give you 0. So we are good to go. Okay. Okay, so there are so many different types of examples. It will always kind of do the same thing. You will write down all your denominators. You will go to the side. You will list out your denominators and then figure out what is the least common multiple. Every fraction gets multiplied by the least common multiple with the effort to wipe out your denominators. So this is like, let's get rid of those denominators as soon as possible type of game here. Now remember, when you see a whole number, if a whole number is part of it, you can write it as a fraction divided by 1. Okay, so my very last example, I'm going to show you one where there is a no denominator over one of the terms, under one of the terms. Okay, so last example is 4x divided by x minus 3 equals 2, no fraction, just 2, plus 12 divided by x minus 3. Okay, so in this example, 2 does not have a denominator, so immediately, if you want to see a denominator there, every whole number is over 1. 2 equals 2 over 1, 2 divided by 1. All right, so trap it and trap it and trap it with parentheses. Everything gets trapped. Keep it 1 unit. And now I'm going to go over to my side, write out my denominators. Oh, look at this. First one has an x minus 3, the second one has a 1, and the third one has an x minus 3. So you guessed it, it's just x minus 3. The least common multiple is x minus 3. Every fraction gets multiplied by x minus 3. X minus 3, x minus 3, x minus 3. In the first fraction, I'm going to cross out the x minus 3 with the x minus 3 completely, leaving 4x. In the second fraction, there is nothing to cancel in the denominator. So 2 is multiplying by x minus 3. And in the third fraction, x minus 3 will cancel with the x minus 3, leaving 12. I'm sorry, that was a plus, not an equal sign there. Let me just change that. There we go. Okay, so steps to solve: distribute, add like terms together, -6 and 12. Be very careful. This term is a -6, not a +6. Don't make the mistake of ignoring that minus there. -6 plus 12 is +6. Group the like terms together by using inverse operations over here. 2x is canceled, 2x equals 6, and divide by 2 on both sides. X equals 6 divided by 2 equals 3. Oh no, what do we notice? What's our domain restriction? Our domain restriction is x cannot equal 3. If I have 3 as an answer, then it has to be rejected. So one line through the answer. Reject. Why? X equals 3 is an extraneous root. Extraneous. Okay, you guys, check my spelling. Are there 2 N's or 1? I'm not really sure. Extraneous root. Basically, it means this: we are not allowed to have it. It is a root that makes the fractions undefined, and we cannot have that. As you know, in mathematics, you cannot have division by 0. So we reject your answer, and there is no solution. And that is a solution. So I'm going to put solution set brackets around my no solution. Okay, and that does it for today. That is our lesson on solving rational equations. I hope you enjoyed the video. If you haven't already, subscribe. Algebra. It's teaching mathematics in the Bronx, New York. Have a great day. Bye.